Hello, viewers. Welcome to today's episode. This is Justice Science Academy. If you are watching this channel for the first time, thank you for stopping by. If you have been following this channel up and be doing the assignment, thank you for always watching my videos. Today, we're going to look at speed, velocity, and acceleration. There's one thing you must note in describing the motion of a body. We note the distance and the time taken for the body to cover that distance. Okay, so let's see what is speed. Speed is defined as the rate at which a body covers a distance. So the rate at which a body covers a distance is said to be speed. That means speed is equal to distance over what? Time. Right? Now let's talk about the unit. We know that distance is measured in what? In meters. For example, is measured in meters. If you don't know how distance is measured in meters, so you have to check my previous video where I did units of measurement. Time is measured in seconds. Okay, like we did in the previous class. If this, from the law of indices, this seconds has invisible power of 1, and we are going to carry it up to have a negative power, so it's going to be what? Meter per what? Second. So the unit of speed is meters per second. Okay, all right. Speed is a scalar quantity. It is a scalar quantity if it says that, in the sense that it has only magnitude or numerical value with no what? Direction. I equally made a video on scalars and vectors, so you can check it up so you can learn more of scalars and vectors. All right. When equal distance is covered with equal time interval, no matter how small the time interval may be, the speed is said to be uniform. A body is said to undergo uniform speed if it covers equal distances in equal time interval, no matter how small the time interval may be. Okay, so if you want to remember that in a nutshell, you can say that if speed is distance over time, then uniform speed will be what? When a body covering equal distance in equal what? Time, the speed is said to be what? Uniform. Okay, so let's see how we can solve problem on speed. Stay tuned. Let's solve this question together. If a bus covers a distance of 200 kilometers in 2 hours, calculate its average speed. For us to be able to solve the average speed, you have to state our parameters. Okay, so we are given the distance of 200 kilometers. So I will say distance is 200 kilometers and time is 2 hours. So let us solve for the speed. Speed is equals to distance over time. We substitute it in what we have. The distance is 200 kilometer and time is 2 hours. Okay, so let's divide 2 into itself 1, 2 into this 1, so I have 0 0, right? The speed is equals to 100 kilometer per hour. Okay, so I've gotten the speed of the bus to be 100 kilometers per hour, but then the unit of speed is meant to be meters per second, but we got this one in kilometer per hour. So I'm going to teach you how to convert from kilometer per hour to meters per second. Okay, let's see how we can do this. Conversion of kilometer per hour to meters per second. For example, I have x, and x is a number and is given in kilometer per hour, and I'm expected to convert it to meters per second. What I'm going to do is to say that x times 1000 divided by 60 times 60. Okay, then anything I have, the answer will be in what? Meters per what? Second. Okay, now how do I arrive at this? We know that 1 kilometer is equals to what? 1000 what? Meters, because I'm changing from kilo to what? 1 meter. All right, then in an hour I have 60 minutes times 60 seconds, right? That will give me 1 hour. So with this, we can now say generalize and say that any number given in kilometer per hour, we can convert it to meters per second by saying times 1000 divided by 60 times 60. Whatever answer we have is now in what? Meters per second. For example, if I say convert 108 kilometer per hour to meters per second. Okay, so what I'm going to do is to say this is 108 times 1000 divided by 60 times 60. Okay, so let's see what cancel out. 0 cancel 0, 0 cancel 0. Okay, so I'm left with what? 108 times 10 is equals to 1080 divided by 6 times 6 is what? 36. But what can go? Let's see if 6 can go or 2 can go. 2 into this, I have 1 and what? 8, that is 18. 2 into this, 5. 2 into this, 40. Is that okay? Let's go again. 2 into 18, I have what? 9. 2 into 5, I have 2, remainder 1. Put it here. 2 into 14, I have 7. I bring down what? 0. Then 9 can go. 9 into itself, 1. 9 into 27, 3. Bring down what? 0. So for me to convert 108 kilometer per hour is equivalent to 30 meters per second. So this is how we can convert. If you are given our speed to be in kilometer per hour, we are expected to convert it to meters per second before you solve your problem. Is that okay? Let's go to the next one. Most times students interchange speed with velocity, but we should know that speed is a scalar quantity while velocity is a vector quantity. Scalar quantity in the sense that it has only magnitude or numerical value or size with no direction. And also velocity is a vector because it has both magnitude and direction. So let's see what is velocity. Velocity is defined as the rate of change of displacement with time. Displacement means distance traveled in a specified what? Direction. Okay, so when we consider the distance traveled in a specified direction is the same thing as displacement. So when we consider the displacement divided by time, we are going to get what? Velocity. So unit of displacement is meter and that of time is seconds. It will give rise to meters per second. Okay, so we now have that speed and velocity, they have the same unit, that is meters per second. You can otherwise say that velocity is change in displacement over time. The change in displacement means we can have final displacement minus what? Initial displacement. That gives us the change. Then we divide it by time to get what? Velocity. We should also know that the slope of displacement time graph will give us velocity. Okay, so that is all we have about velocity. So let's look at acceleration. Acceleration is defined as the rate of change of velocity with time. It is also defined as the increasing rate of change of velocity with what? Time. So I'm trying to say that acceleration is change in velocity over time. All right. Now the unit of acceleration A is meters per second what? Square. Okay. So an acceleration is also a vector quantity because it has both magnitude and direction. Now if you say that acceleration is change in velocity over time, then for us to bring out the change, we have to know that acceleration is final velocity minus initial velocity over what? Time. Is that okay? When we subtract the difference, we divide it by time. That will give us our acceleration. Okay, we should also know that this acceleration can also be defined as when velocity change increases with time. But in a situation whereby the change in velocity decreases with time, it is called deceleration or retardation. So we can say that retardation is opposite of acceleration. Even though it's the same unit, we are going to get a negative sign for retardation or deceleration. So let's prove this acceleration more. If you are watching this channel for the first time, please give it a thumbs up and subscribe to this channel for more educative videos, because I'll be posting videos like this virtually every day to help you grow your knowledge in physics and also in mathematics. Alright? So I want to prove this acceleration more. If we say that A, which is our acceleration, is equals to final velocity minus initial velocity divided by what? Time. Divided by time. So if V is equals to final velocity, then U is initial velocity and T is time. Our acceleration A is equals to V minus U over what? T. So this is the relationship between acceleration and velocity with what? Time. We can also note that when a body starts from rest, or if a body is not moving at all, it means the body starts from rest. And once the body starts move from rest or starts from rest, this is the terms we normally use, it automatically means that its initial velocity u equals what? 0. So once you know that, you can easily find for your acceleration, for your time, or for your final velocity. Remember that deceleration is opposite of acceleration, and if you're asked to calculate deceleration, you're actually looking for A, but your answer will be in negative sign. Let's look at an example of question on acceleration. Stay tuned. Let's see this example. A body starts from rest and accelerates uniformly at 5 meters per second square until it attains a velocity of 25 meters per second. Calculate the time taken to attain this velocity. So for us to solve this problem, something you must take note. When a body starts from rest, automatically u is equals to 0. Okay? Then it accelerates. This is acceleration uniformly at what? 5 meters per second square, and attains a velocity that becomes our final velocity. V is equals to 25 meters per second. We are asked to find what? The time. Okay? So we are going to use the formula for acceleration. A is equals to V minus U over T. Since we are looking for time, we can just say T, or this over 1 cross multiply, T is equals to V minus U over what? Over A, sorry. Okay. Now for us to solve, let's put in our values. What is my V? I have 25 minus 0 divided by what? 5. So T is equals to 25 over 5. If I divide itself 1, divide this 5. So I have my time to be 5 seconds. So this is how we can solve problem on acceleration speed. I hope this video was helpful. So please, if you are watching this channel for the first time, give it a thumbs up and subscribe for more educative videos. So I'll be posting videos like this virtually every day to help you groom your knowledge in physics. I'm going to put up an assignment and you have to solve it and drop your answer in the comment section. See you next time in my next video. Bye.